Welcome back to ChemExam Explained, where the aim is chemistry clarity, exam mastery. In today's video, we will be looking at CAPE Chemistry Unit 2, 2023, Module 3, Industry and the Environment. Let's go. 3A. Chlorine is produced in industry by the diaphragm cell electrolysis of saturated aqueous sodium chloride. This is brine. Part 1. Write half equations to represent the reactions taking place at the anode and cathode in the diaphragm cell. So at the anode, it is the positive electrode. So the chloride ions, which are negative, will be attracted towards the positive anode or the positive electrode. Now, the process taking place here is oxidation. This is where electrons are added on the right-hand side of the equation. At the cathode, we have hydrogen ion, which is positive, being attracted to the negative cathode. And this process is reduction. And this is where electrons are added on the left-hand side of the equation. Now, these are two half equations representing oxidation and reduction. Part 2. Deduce one reason why the anode in the diaphragm cell is not made of steel. Now, the anode in the diaphragm cell is made of titanium and not steel, because the chlorine produced at the anode will react with the steel, which is an alloy of iron. And so if you look here, you'll see that the titanium is the anode and the steel is the cathode. So the chlorine that is produced here is coming in contact with the anode. And if it was made of steel, which is an alloy of iron, then you'd have some reaction taking place with the iron and the chlorine. Part 3. In both the production of chlorine as well as the manufacture of chlorine-containing compounds such as PVC and CFCs, environmental issues are commonly raised. Discuss two environmental concerns associated with each of the following. The first one is the production of chlorine using the diaphragm cell. Now, first thing is the diaphragm cell is made of asbestos. Now, dried asbestos can cause respiratory problems, as well as it is carcinogenic, which means it is cancer-causing. 2. Chlorine gas, if leaked, is poisonous, as well as it can cause choking. 3. If sodium hydroxide is leaked, it will increase the pH of the water, causing organisms to be killed. This is because the organisms within the water cannot operate at such high pH. The other environmental concern has to do with the manufacture or use of PVCs or CFCs. 1. The production of CFCs contribute to the depletion of the ozone layer. 2. PVC is not biodegradable, which can cause pollution. And 3. PVC generates dioxins when it is incinerated. 3B. Carbon tetrachloride is an effective fire extinguisher, but it is no longer used because of its toxicity and its role in the depletion of the ozone layer. In the upper atmosphere, a bond in CCl4 breaks and reactive species are formed. Part 1. Identify the condition that caused the bond in CCl4 to break in the upper atmosphere. Deduce an equation for the formation of the reactive species. Condition. The presence of UV light is what is used to break the CCl4 bonds. The equation is CCl4 in the presence of UV light will form CCl3, which is a radical, plus chlorine radical. Now, a radical is a species with an unpaired electron. Part 2. The reactive species formed from CCl4 act as catalysts in the decomposition of ozone. Write two equations to show how each of the species act as catalysts. Equation 1. Chlorine radical will react with ozone to form chlorine monoxide radical plus oxygen. Now, the structure of ozone is O, single bond, O, double bond, O. And if we put on the lone pairs, it will be 2, 4, 6. This would be 2, 4, 6, 8, 2, 4, 6, 8. So this is the structure of ozone. Now, the radical, which is very reactive, will break a bond from the ozone, removing an oxygen atom. That oxygen atom will be attached to the chlorine radical, forming chlorine monoxide radical plus O2. For equation 2, the chlorine monoxide radical will now react with an oxygen radical to form chlorine radical plus oxygen. These two equations show the destruction of ozone. Now, remember, we can check to see if these equations are correct. Now, for the destruction of ozone, what must happen is that O3 must be broken up by an oxygen radical to form two oxygen molecules. So you'll see that Cl radical plus ozone forms ClO radical, which is the chlorine monoxide radical, plus oxygen. First equation. The second equation is the chlorine monoxide radical combines with an oxygen radical to form chlorine radical plus oxygen. Because this time what will happen is that the oxygen radical will combine with the other oxygen from the chlorine monoxide to form Cl radical and oxygen. Now, if we combine these two equations, you'll end up with O3 plus oxygen radical to give you two oxygen molecules. We simply remove the species that are on opposite sides of the equation. So here we have Cl radical on the left-hand side. Over here, we have Cl radical on the right-hand side. Here we have ClO radical on the right-hand side, and here we have ClO radical on the left-hand side. So we simply say O3 plus oxygen radical to produce two oxygen molecules. And this is how we check that these two equations are correct. Again, this is showing the destruction of ozone. Remember that the Cl radical is very reactive, and it is acting as the catalyst to continue the breaking up of ozone. Because after the destruction of ozone forming O2, it is regenerated. So you must note that the Cl radical was regenerated to continue the depletion of more ozone. And it will continue to do so unless it is removed from the environment. Part 3, state the name given to this upper atmosphere. So the name where this is taking place in the upper atmosphere is the stratosphere. Part 4, discuss the importance of the ozone layer to all life on planet Earth. Ozone layer absorbs harmful UV radiation, which prevents incidence of skin cancer and cataracts. It prevents destruction of living tissue or vegetation. Now, in the event that you're asking, where did this oxygen radical come from? You can see here, I have an equation to show you just that. In the first instance, the energy from the radiation, if you will recall that E is equal to H nu, then that energy is enough to break the bonds between ozone, forming oxygen molecule and an oxygen radical. Now that oxygen radical will now break up ozone to form two oxygen molecules. 3 part C. The carbon cycle describes the process in which carbon atoms continually travel from the atmosphere to the Earth and then back into the atmosphere. Figure 1 presents a simplified version of the carbon cycle and some processes labeled A to E. In this case, we're looking at a tree or a plant, and we see the sunlight, and the sunlight gives energy to the plant. So if we're looking at that process, we're to identify the components labeled A, B, C, D, and E in figure 1. So the process taking place at A is photosynthesis. B, we see where we have an animal and it is releasing carbon dioxide into the atmosphere. So the process taking place at B is animal respiration. Part C, if you observe the diagram, you see we have dead organisms and waste products going to C. So the process here is the formation of fossil fuel. D, here we have a plant and it is going into the atmosphere. So at D, we have plant respiration. Part E, if you look here at the roots of the plant, this is producing root respiration. Those are your 5 marks. C, part 2. Some Caribbean islands are encouraging citizens to use solar energy to generate electricity for household use. Explain how this initiative will help maintain levels of oxygen and carbon dioxide in the atmosphere. Well, first, it will decrease combustion of fossil fuels. It will decrease the amount of carbon dioxide being added to the atmosphere, which of course contributes to global warming. It will also decrease the amount of oxygen being removed from the atmosphere. D, part 1. Define each of the following terms. Reuse. Reuse means to find another use for an already used item. Reduce. This means to lessen the volume of product being used. Recycle. To convert an already used item into another useful product by a chemical process. D, part 2. 2 suspected pollutants present in runoff from a community landfill are lead-2 ions and nitrate ions. Complete the table below outlining simple laboratory tests that would confirm the presence of Pb2+ and NO3- ions. The ions are present here on the left-hand side of the table, Pb2+ and NO3-. Now, what test could you use? Now, I have 3 tests here. You can give any one for your answer. First one you could use is to add potassium iodide dropwise to your test tube containing the sample. You should observe a yellow precipitate. You could also add dilute hydrochloric acid dropwise to your sample, and you should observe the formation of a white precipitate. You could also add dilute sulfuric acid dropwise, and you should also observe the formation of a white precipitate. For the identification of nitrate ions, you could carry out several tests. You could use any one of these as your answer. You could add concentrated sulfuric acid as well as copper metal or copper turning. You should observe brown fumes and the formation of a blue solution. You could add iron 2 sulfate followed by concentrated sulfuric acid. You should observe a brown ring at the junction of the 2 liquids. And finally, you could add aqueous sodium hydroxide, then zinc powder or aluminum powder. You should observe a pungent odor, or moist litmus paper turns blue. Now, the pungent odor is because of the formation of ammonia gas. And the reason why the red litmus turns blue is because ammonia is an alkaline gas. This is the end of question 3, module 3, 2023. Please remember to like, subscribe, and click the notification bell so that when new videos are uploaded, you will be notified. Thank you.